everyone and welcome to the internet. So what we're going to be doing in today's triple chemistry lesson is having a look at the effect of surface area on the rate of the reaction. So to start us off then, we've got a couple of questions. Those of you with target grades up to a grade 5, it's the 2 on the left. Those of you with target grades over a grade 5, it's the 2 on the right. So answer those questions in your book for me. I'll just give you about 3 minutes to do that. Let's mark those answers then. So for the up to grade 5, our first question, the trend we see when we increase the concentration is that increasing the concentration increases the rate. So give yourself a tick if you've got that right. For question 2, the trend we see with pressure is that increasing the pressure increases the rate. Again, give yourself a tick, add those up and give yourself a score out of 2. If you did the grade 5 and up questions, then our actual explanation side of things is that increasing the concentration increases the rate. Tick for that bit. As the concentration increases, the particles are more crowded. A tick for that one. And then finally, we get more frequent successful collisions. A tick for that. So question 1, maximum of 3 marks there. So 1 for increasing concentration increases the rate. 1 for the particles become more crowded as the concentration increases, and 1 for the more frequent successful collisions. Then for question 2, first mark is for saying increasing the pressure increases the rate. Second is for saying that as pressure increases the particles are more crowded. And our third mark is for saying that there are more frequent successful collisions. So add those up for me and give yourself a mark out of 6.
chemistry teachers, we're all very familiar with demonstrating the effect of surface area on reaction rate. Typically, we would do this with marble chips reacting with acid on a top-down balance. However, what I'm about to show you is an entertaining and quite spectacular alternative. Milk powder contains carbohydrates and fats, both of which release energy on combustion. Now, if this milk powder is arranged in a small pile, then the effective surface area is quite small, meaning that the reaction is very slow. However, if that same powder is sprinkled as a fine cloud, the reaction rate is much faster. To do this demonstration, you should take a meter ruler and fix a splint to the end of the ruler, and then arrange this so that the splint can burn horizontally a few centimetres above a protective bench. This is important so that the falling milk powder won't extinguish the flame, as it would if you were using a candle. The height that you sprinkle the powder from will dictate the height of the fireball produced, and you should always take care to step back quickly as soon as the bottom of the cloud ignites. Now, if you're feeling brave, you could try sprinkling that from a greater height.
So what we just saw in that little demonstration video then was how surface area is going to affect the rate of reaction. Now, sadly, we don't get to burn stuff in our own homes. Seriously, do not try that at home. But what we would have done is actually that demonstration. So we'd have actually had a chance to play with that in class. Something to look forward to when we finally get back to school. Now, in terms of the experiment you would have done personally, I wasn't about to let you all create fireballs in the classroom because, well, we'd end up on the Astro with another fire alarm. So instead, what we'd have done is we'd have done an experiment using marble chips and acid. So what we've got on the screen at the moment is an outline of the practical that you would be doing. So what I'd like you to do is write this down because they can ask you about these rates of reaction experiments. So if you write this down just so that we've got a record of how to do it, and when we're all back in school, we'll do these experiments. So the first thing we're going to do then is we're going to measure 25 centimeters cubed of hydrochloric acid and place it in our conical flask. We're then going to weigh 3 grams of our large marble chips on our balance. We then set up our upturned measuring cylinder, which is filled with water. We'd add our 3 grams of marble chips to the acid and start timing. And at this point, we'd connect our delivery tube into our conical flask and then make sure the other end is under the upturned measuring cylinder. 30 seconds later, what we do is we record the volume of gas that we've made. We do the exact same thing, just using medium-sized marble chips and small marble chips. Always 3 grams though in each case. So I'll leave this up for a couple more minutes so you can get those points written down in your books. Okay, next thing I'd like you to do then is to design me a results table that would allow us to record the results in this experiment. So make sure you're thinking about headings, units, all those important things that we would need for a results table, and then write that results table into your books. So the outline of your results table with all the correct headings, put that into your book. I'm just going to give you a couple of minutes to have a go at designing this. Hopefully we came up with a table something like this. So we've got a column for the size of the marble chips, and we've got small, medium and large. We've got a column for the volume of the gas, and then you may or may not have included the time, because obviously we did it 30 seconds in each case. But I've also added at the end the rate in centimetres cubed per second, because obviously the whole title of today's lesson is rate and surface area. So if you haven't got a results table, then I'd suggest you pause the video here and get that table written down for me. So what I've got for you next then is a video of someone actually carrying out this experiment. So this means you are going to be able to fill out those values in your table from the experiment that they're doing. So if you haven't already copied that table as it is, so with the size of marble chips, the volume, the time and the rate columns, then pause the video and copy that now. Because as we watch this video of the experiment, I want you to write down the volume and the times for each of those three sizes of marble chip.
Welcome to finding the rate of reaction between marble chips and hydrochloric acid. Now, marble chips or calcium carbonate react with acids to produce calcium chloride, water and carbon dioxide gas. So we can measure the carbon dioxide gas and time how long it takes to collect a known volume. Now we're going to investigate large marble chips, medium marble chips and small marble chips. Now we should know from the theory that as we increase the surface area, going from large to medium to small, we increase the number of particles available to collide with the hydrochloric acid. Therefore, there are more successful collisions per second and a faster rate of reaction. So this means we're going to collect gas more quickly as the chips go from large to small. So with this in mind, we know that the large marble chips are going to react more slowly. So we're not going to get a lot of gas collected very quickly. So I'm going to be using a small measuring cylinder for this one. Now when we collect a gas, we can't just use a measuring cylinder because it's already filled with gas. So we need to make sure we've got water in this. And we can do this by popping it in some water, turning it upside down, and it's now filled with water. The delivery tube goes into the bottom of this, and because I'm doing this on my own, it can be clamped. So we're going to clamp it. Now, in here, I've got 3 grams of large marble chips. I'm going to be adding 20 centimetres cubed of hydrochloric acid. As soon as I've added it and placed the bung back on, I'm going to start my stopwatch, and I'm going to time how long it takes to collect some gas. Now, it doesn't matter how much gas I collect, as long as I know the time. So I've got some markings on here to make it easy to see. We've got 4, 6 and 8. So depending on how quickly we're going to collect it will depend on the volume we're going to collect. So here we go. Acid in, bung on the top, start the stopwatch. So you can see we're collecting the gas. It's not going very quickly. So I think I'm going to go for 6 centimetres cubed. So when it gets to the bottom of the white label, I will stop the stop clock. And go. So we've collected 6 centimetres cubed, and it's taken me 19.56 seconds. Because we've got a human reaction time, I'm going to round it to the nearest second. I'm just going to take it to 20 seconds. So I've recorded that on my results table. Now we need to set up for the medium chips. Now with the medium chips, we know that they're going to react a little bit faster. So this measuring cylinder is going to be too small. So I'm going to use a slightly larger measuring cylinder. We're going to be going for a 25 centimetre cube cylinder. And again, I've put some markings on it to make it easier for me to see. Again, we need to fill it with water, so we can do this easily by popping it in there, turning it upside down, delivery tube under the bottom, and we can clamp this. Okay. So again, I've got 3 grams of marble chips. I'm using clamps because it's only me doing it, and you need 2 or 3 people to do this to hold the equipment, or you can clamp it. So we need to reset the stop clock, get ready with our 20 centimetres cubed of acid, and off we go. Bung in, start the stopwatch. There we go, here comes the gas. And again, it's going quite quickly. I think I will stop it at 15 centimetres cubed. Here we go. And stop. So we've collected 15 centimetres cubed, and it has taken us 33 seconds. And lastly, we're going to collect small marble chips. And as we know, we've increased the surface area, and we're going to get much faster reaction rate. So we're going to go for a large measuring cylinder, because we're going to get gas given off much more quickly. Okay. You don't have to use a measuring cylinder. You could use a test tube or a boiling tube, provided you know the volume of gas that they will hold. And obviously you'd have to collect the whole test tube or boiling tube full of gas, the time how long it took to fill. So we need another 25 centimetres cubed, 20 centimetres cubed of acid. Go. Here are our small marble chips. And reset the clock. And we're ready. Here we go. Now you can see this one's reacting much faster, producing a lot more gas. So, looking at the speed of it, I think I will probably go for 50 centimetres cubed of gas, because we're getting it quite quickly. Here we go, and stop. So, we've got 50 centimetres cubed of gas, and it has taken us 23 seconds. So, all we need to do now is calculate the rate of reaction. Rate of reaction is calculated by volume of gas collected divided by the time taken, and the unit will be centimetres cubed per second. So, that's how we find the rate of reaction for a reaction that produces a gas. Thank you for watching.
So hopefully our results table now looks something like this. So for our small, we got 50 centimetres cubed of gas in 23 seconds. For the medium, we got 15 centimetres cubed of gas in 33 seconds. And for the large, it was 6 centimetres cubed of gas in 20 seconds. So what I'd like you to do now then is to calculate the rate for each of those marble chips. And hopefully we remember that to calculate the rate, we do the volume divided by the time. So grab a calculator and then work those three out for me, filling in the rate in that third column on your results table. So I'm just going to give you about a minute and a half to do that. Okay, let's check those answers for our rate then. So obviously any of these you've got right, give yourself a tick. So for the small it should be 2.17, for medium 0.45, and for the large 0.3. So add up those scores and give yourself a mark out of 3 for the rates that you've calculated. So what I'd like you to consider then is, how could we display this data? What type of graph would we use? Write that answer down in your books. Just 20 seconds. What type of graph would we use for this data? The correct answer is a bar chart, because if we're looking at it, the size of marble chip, it's discrete data, okay? They're individual categories. So therefore, we need to use a bar chart. That's the only correct answer. Give yourself a tick if you got it right. Now, what I'd like you to do is to have a go at writing your conclusion. So we've seen the experiment, we've got our results, we've processed our results. I want you to finish off the sentences on the screen. Now, the first bit, I haven't given you the words yet, just want to finish off what you found out. And then the second part, there's 3 gaps, the 3 words are at the bottom of the screen. Now, there are some little pictures at the bottom that might help you with answering this. So I'm going to give you about 3 minutes to get that done. Let's check those answers then. So hopefully the end of that first sentence is along the lines of, I found that when the surface area increases, the rate of reaction increases. Now, some of you may have just talked about the fact that when the particle size gets smaller, and that's okay, but we really need to be talking about surface area. So remember, if we've got one big lump, then that's actually got a small surface area. Whereas if we break that one big lump up into lots of smaller ones, or even a powder, then we increase the surface area. So as surface area increases, the rate of reaction increases. And the reason for that is that when we've got a larger surface area, then there's more particles of the marble actually exposed to the acid. Look at the pictures at the bottom. You can see in the one big lump, obviously there's only a certain amount of space that the actual acid can come into contact with the marble over. Whereas if we break it up into smaller pieces, then there's a much greater surface area, which means there's more marble particles exposed, and therefore there will be more frequent successful collisions. So once more, we've gone back to that phrase, more frequent successful collisions. Obviously tick any of those you got right. If there's anything you didn't get right, then put the correct answer in. I'll just leave that up for another 10 seconds for you. So last thing for today then is the plenary question. So if your target grade is up to a grade 5, question on the left, over grade 5, the question on the right. So I'll just leave this up here for about a minute today to give you a chance to answer. As always, you can find the answers to the plenary over on my website, sciencewright.weebly.com. You'll also be able to find that under the Internet tab. Just select the week that we're in, and then you'll be able to find things like the lesson PowerPoints, the answers to the plenary, any additional work, and if there's any little experiments I thought you could do at home, then they're there too. So have a look and get using that.